Okay, welcome back. Just math, y'all. We're going to do some fractions. So let's get started. Okay, let's just go to try not to think too hard about these fractions. We're going to go quickly. You can click through the video, stop the video anytime you want to, and do an example. We're just going to go through them real quickly. Okay, so understanding fractions. Now, remember in class, I may have mentioned, but if I didn't, here we go. I'm going to mention it now. You need a calculator that does fractions so that you have a backup, because fractions are hard for some people and we don't want you to get them wrong just because they're hard for you. We want you to be able to get them right. So I am going to explain them just quickly. So the concept of a whole being divided into pieces is the meaning of fraction. So now you learned this back in grade school when you did pizza. And so we would take a whole pizza and we cut it up into pieces. And most pizzas are cut into 8 slices, and that looks pretty bad. But this is eighths. I can't spell eighths. E-I-G-H-T-S. Eighths. T-H-S. There we go. Eighths. And so this one would be cut in, we'll just do, we will do fourths. Okay. And so if I talk about this piece right here, that's one piece. So that's 1 1/4. The bottom number is actually not a quantity. It is the size of the piece or the amount of pieces that the whole was cut into. But when we're talking about 1/4, I'm talking about one of them, just one piece of pizza. If I eat 1/4 of this pizza, then I've eaten one piece. But now this one over here is cut differently. I can still eat the same amount, but over here it's 2 pieces. This would be 2 pieces, and each piece is called an eighth. And it's the same amount of pizza. It's the same amount. And that's really important. So 2/8 is the same amount as 1/4. Okay, because it's the same amount of pizza. It's just how big are the pieces. You know that. So that's how we started learning fractions with pizza. We also use fractions a lot with money. And I like to use money because it makes sense to most people. So like if I had a $50, a 50-cent piece, which nobody ever knows where they are anymore, and I can't spell pieces, so y'all forgive my spelling. For a 50-cent piece, well, that's a $50. That's a $50. That's a 50-cent piece. It takes 2 50-cent pieces, and if I only have one of them, then that's a $50. Okay, but I also have dimes and quarters and nickels. So quarters, if I have 2 quarters, I have one 50-cent piece or 2 quarters. Well, that's 2 quarters. It's 2/4 because it takes 4 quarters. And then, of course, 1/2 is equal to 2/4. It's equivalent. So we use fractions, and I'll throw those back in there. Okay, so now this is the understanding of fraction representation of 1 gives us meaning behind all our fraction algorithms. And so if I have 4 slices of this pizza, 4 slices of that 4th pizza, I have 1 whole pizza. Or if I have 8 slices of that pizza, I have 1 whole pizza. If I have 2 50-cent pieces, I have 1 whole dollar. Or if I have 4 quarters, I have a whole dollar. So this idea of 1, this representation of 1 is very important. It's so important that I want you to really think it through. This is always 1, and in algebra we'll say stuff like stuff over stuff equals 1 if they're exactly the same. So if I have ABC over ABC, guess what that's equal to? That's equal to 1. Okay, this is a huge concept with fractions. I want to make sure you got that. Okay, because when you multiply and divide a number by 1, it doesn't change what we have. You know that. You know that 3 times 1 is 3. Well, if I have a fraction 1/2 and I multiply it by, say, 8 over 8, that gives me 8 over 16. That's the same amount. That's the same amount. Because when you multiply by 1, you don't change the quantity of what you have. And I can also divide. I can divide. And this is called making equivalent fractions. We can multiply or divide by 1, and this is going to give us a different numerator and denominator, but it's going to give us something that's equal to it. So I could start with, say, 10 over 40, and I could divide both of those by 10. And remember, this is 1. Multiplying, dividing by 1 doesn't change what you have. And I guess 1/4. These two are the same. They're the same quantity. And if I took 3, I don't know, 3/4 and multiply those by 5, well, I have 15/20. This is multiplying by 1. And so these are the same quantity. And this is just a real important concept to understand. And so it's not something that we do all the time, but we do this a lot when we're dealing with fractions. When we divide, we call it reducing or putting it in lowest terms. That's what we call as terms. There we go. Making equivalent fractions, we're reducing, we're putting in lowest terms. This and this are equal, but this one is expressing it in lowest numbers, the lowest digits. That's what's called. Now over here, this one's the lowest term, but that's the one we started with. Now, why would we do that? Well, sometimes we need to be able to do things in a different format. To be able to add and subtract fractions, we got to be able to have the same format. And so we would do this in order to prepare to get ready to add and subtract. So let's keep moving forward. Okay, so let's talk about this reducing thing, also known as putting lowest terms. You can divide both the numerator and the denominator by the same number, that's that 1, until they no longer can be divided by the same number. So say I had 48 over 36. Okay, I could sit here and I could divide the same number over and over again. I know that 2 is going to go into it because they're both even. You might not know that. And that's going to give me 24, and that's going to give me 18. And so this is dividing by 1, so these two have the same quantity, but I can keep going because I can do 2 again. And that gives me 12 over 9. And now I can't do 2 anymore, but I could do 3. And that gives me 4 over 3. So that's the lowest terms. Now that's one way of doing it. That's the general math method. There is an algebraic method. Let's look at the algebraic method. It's kind of fun. And it starts out with factor the numerator, denominator, and then cancel the common factors, also known as divide out of 1. So this is another way of doing it. Say you know that 4 times 12 is 48. So I make that 4 times 12. Well, I can keep factoring. 4 is 2 times 2. 12 is 3 times 4. I could keep going because the 4 is 2 times 2. That's called prime factoring. That's what that's called. You may remember that. And then 36, well, 36 is 6 times 6, which is 2 times 3 times 2 times 3. And that can be what we call cancel out. So there is your magic 1. Here is another 1. Here is another 1. Some people just X them out. I make them 1s. And this is my answer. That's 2 times 2 is 4 over 3. So I get the same answers I got before, but one of them is the lowest terms through a general math method, and one of them is through an algebraic method. Now, if you have a calculator, you can type 48 over 36 in a calculator and hit enter, and it should give you 4/3. That's the shortcut. Okay, so now we're going to come back on the next video and multiply fractions.